welcome to our channel Gyan Shree Education tutorial. Myself Himani Dixit, and we will study further the neem reaction, and our next neem reaction is Hofmann Rearrangement. In this reaction we have amide in the presence of base, that is we usually take OH negative. When it reacts with Br2, what we get are NH2, that is primary amine. In this reaction, amides get converted into primary amine. Amide gets converted into primary amine. Here we notice that this carbonyl group gets removed, so we get amine which is one carbon less than the starting material. Amine containing one carbon less than the starting material. Now let us study the mechanism of Hofmann rearrangement. We have amide, that we have RC double bond O and H2. When it gets treated with base, either OH negative or we have hypohalide, that is OBr negative, then what will happen? It will upset the proton. We have RC double bond O and H negative, and in the reaction mixture we also have bromine. So when this gets reacted with the bromine, what will happen? RC double bond O and H negative charge plus Br. When this negative charge attacks at this bromine, this bond will break and minus Br negative will remove out, and we left with R C double bond O and Br H. Now again base will react with this species because it also have one more hydrogen here, that it can be removed or extracted by the base, and we get OH negative here, R C double bond O and negative Br. Now what will happen? When this negative charge will come here, this R group will migrate to the nitrogen side and Br will remove, and this is also the rate determining step of the reaction, that is the removal of the bromine group is the rate determining step. So we left with, when this R group shifted towards the nitrogen, we left with C double bond O double bond and R, and it is our intermediate. Which is called isocyanate. Now what will happen when this isocyanate gets treated with water? R and double bond C double bond O. What is this? Is it our intermediate? When you get treated with H2O, we get R C double bond O R NH C double bond O OH. This is our carbonic acid. Which is highly unstable, so it gets decomposed. That is, removal of water takes place. So we get R and H2, and it is our primary amine. So what we conclude from the Hofmann rearrangement that it is intramolecular SN2 mechanism reaction, and here NGP or ankymeric resistance, Also seeing what do we mean by NGP? NGP stands for neighboring group participation. Neighboring group participation. Now what do we mean by neighboring group participation? Whenever we have a leaving group in the substrate, then the group which is in neighbor side, so it will force the reaction and remove the leaving group. So what we have seen that here we left with R C double bond O, and here we have Br and a negative charge. Here what will happen? These nitrogen have negative charge and also lone pairs. When this negative charge come here, this will force the R group to migrate towards this side and remove the Br group from this reaction. And this reaction proceeds through concerted mechanism. This reaction proceeds through concerted mechanism. Or we can say in single step. Here, there is no change of stereochemistry. There is no change of stereochemistry. For example, if we have C SO2Cl, here we have H and C double bond O and H2. When this compound is treated with base with bromine, now what will happen? This amide groups gets converted into amine group, and the stereochemistry of this carbon, that it is a chiral carbon, remain as it is. So here we have H, here we have tertiary butyl, SO2Cl, and we left with NH2. It is our amine, and there is no loss of the stereochemistry, and it is a very important feature of this reaction. And here no crossover products will form. That is, no crossover product will form. For example, if we take R C double bond O NH2 and another molecule of this which is isotope of this, where we have two alkyl groups. Here is R and this is R star, and this is nitrogen, and this is another isotope of the nitrogen that is represented by N star. So on this treatment with base OH negative and in presence of bromine, what will happen? We get two products. rather than 4. R NS2 plus R star N star H2. From here, we can conclude that the reaction proceeds via concerted mechanism and there will be no crossover product formation. Further, we will study the next example in which we will study what will be the effect of this group X on the rate of the reaction. More the electron donating the X group, that is, more electron donating X group, more will be the rate of the reaction, because this whole group will migrate towards nitrogen, where the nature of the nitrogen is electron withdrawing, or we can say nitrogen here will act as electron acceptor group. So here the order is, when X is OMe, the rate will be maximum, then for methyl and for Cl, and here it is least for nitro group, because we know nitro group is a deactivating group. It will decrease the activity of this phenyl group. So further we will study the applications of Hofmann rearrangement. We have the applications. First of all, we have, it converts amide into amine. Secondly, it do not affect the other functional group present in the reactant compound. It do not affect on the other functional groups. And it is also helpful in the formation of amino acid. Also helpful in the formation, or we can say synthesis of amino acid. Synthesis of amino acid. Now we will study the synthesis of amino acid. Now what will happen when it gets treated with base OH negative? It will abstract this proton. So here we have CH2, C, double bond O, and negative CH2, C, double bond O, and now again here OH negative will act as a nucleophile and will attack at the carbonyl group. So when this acts as a nucleophile, this double bond will shift towards the oxygen atom here, and it will acquire negative charge. So we get CH2, C, double bond O, and negative CH2, C, O negative, and OH, and this bond will remain as it is. So here look at this, when this negative charge again come back at its original position, this bond will shift towards nitrogen. Now here when we provide acidic conditions for this, we get CH2, C, double bond O, and H2, CH2, C, double bond O, OH, and this is our amino acid, that is beta aniline. And this is the whole mechanism of the Beckmann rearrangement. Thank you for watching, and if you like my videos, please subscribe to my channel and give it a thumbs up, and if you have any queries, please write in the comment section so that I can know in which field you are facing the problems. Thank you for watching.